So all of our discussion on refraction is ultimately leading up to our discussion on lenses. And when there are two types of lenses, and we're going to take a look at both of them. This first picture that we see right here, this is a converging lens. It's called this because the light rays that come in parallel, as you can see in this other image, these rays coming in are parallel. They all converge to a single point after refracting through the lens. It's thickest in the middle, and it can be called a biconvex lens. The second image that we see here is a diverging lens. And it is called this because parallel rays sent in go away from each other afterwards. They diverge. So this type of lens is thinnest in the middle and can be called a biconcave. This should say biconcave lens. So when light passes through a lens, the light is refracted twice. Okay, so right here we see our first refraction, and right here we see our second refraction. The light refracts when it enters the lens, and then again when it leaves the lens. But we simplify it by only having one refraction, and that occurring in the center of the lens. So a lot of times when I do a lens ray diagram, I'm just going to draw a dashed line somewhere, and that's going to represent the center of my lens. So our terminology when we're talking about lenses is slightly different than mirrors. We still have the imaginary line that runs through the center of the lens called the principal axis. Instead of a vertex, which is the center of the mirror, the center of the lens is called the optical center. Lenses have two focal points, f and f prime. F is called the primary focal point, or the principal focus. And f prime is called the secondary principal focus. These two focal points are the same distance from the optical center, but they're on different sides of the mirrors. And instead of using the center of curvature, we're going to use 2f and 2f prime. So, for both converging and diverging lenses, we need to label some points on this. So, this line, as always, is my principal axis. Okay? This point right here is my optical center. So I'm going to put PA there, O, F, F prime, 2F and 2F prime. Okay. So then F occurs right here where all of these rays come together. And 2F then is over here. F prime is on the opposite side, and so is 2F prime. Now, diverging lenses is same sort of thing. So here is my optical center. This point where if I was to trace my refracted rays back, all of them would meet, is my primary focus. So that makes this 2F. This point is F prime then, and this would be 2F prime. Again, this is still my principal axis. So, drawing ray diagrams for lenses is similar to mirrors, but instead of reflected rays, they're going to be refracted. The other key difference is that virtual images appear on the same side as the object. And there are only 3 rays. Okay? Ray 1 on my notes is going to be orange. It's going to come in parallel to the principal axis and refract to go through F. Now we are talking about converging lenses here, not diverging yet. My second ray is going to be blue, and this goes through F prime and reflects parallel. And then finally, it just goes through the optical center. Okay, so let's set up to do our first one. I need my ruler. Well, where did it just go? Okay, so here I am. My optical center is always here, so here's, oh, I can't draw that yet. Okay, F is 3 centimeters. Now, if we look back a page in our notes, our F for a converging lens is to the right. So 1, 2, 3. That's where my F is going to be. So then 2F, I multiply that by 2. 4, 5, 6. And I go the same thing on the other side. 1, 2, 3, oops, 4, 5, 6. I don't know why we won't do that one yet. My object distance is 7, so here's where my object's going to be. Okay, so now I can do some actual labeling. Here is F prime. There's 2F prime. Here's O. Here's F. Here's 2F. Now my object height, according to this, what in the world? It's not cooperating. I think my fingers have dinner on them. My object height is just 1 centimeter. Okay, so now we can start with our rays. We're going to do them in the right order. Okay, so ray 1 goes in parallel to the center of the mirror and then refracts to go through F. Uh-oh, Kaylee's crying. The second one, my blue ray, goes, remember they always all have to hit the top of the object, through F prime to the optical center, or toward the center of the mirror, and then comes out parallel. And then finally, my third ray, use this one, just goes through O. Nothing weird about this one. It just goes straight through. So, conveniently, I have an image being formed right here. Now, the size of it, it is smaller. The attitude is inverted. The location is between F and 2F. And the type is real because it's on the opposite side of the mirror. The image is real. Okay, so we have 2 more examples with this type of mirror, or lens, sorry, and then we will be moving on to diverging lenses. So, here we go. If you think, oh, I'm getting this, this isn't too hard, then please go ahead and pause the video and try them and then come back and watch it and see, did you do them correctly? So F is still 3. 1, 2, 3. That makes F, or 2F, 6. 4, 5, 6. 1, 2, 3. Hi, peekaboo. 4, 5, 6. Do you want to come say hi to everybody? Do you want to say hi? Tell them. Tell the kids about it. Some of them are going to be like, oh, let's just skip over this part because this is Loveberry's kids talking. Give me a kiss. Mwah. Bye, baby. And the object is located at 6 centimeters. So this is also where my object is located. All right. Let's go ahead and label O, F, 2F, F prime, 2F prime. The object height this time is 2 centimeters. She doesn't really like getting a diaper or pajamas put on, and that's what's going on. So if you hear her cry, I am sorry. All right, so the first one goes in parallel. It's my orange ray, so I need to change my pen color. In parallel, and then bends to go through F. Oops. My second ray I am having a heck of a time today, guys. Goes through F prime. This is my blue ray, so I need to change colors again. And then comes out parallel. And then finally, my last ray just goes through the optical center. And here is my image. Now I can tell you that mine is a little bit off. Okay, it is supposed to be the same size. It is still inverted. It is at 2F. And it is real. Okay, last example, and then we're going to move on to diverging lenses. And then we will be done, and you will be able to do the practice with that. So, I need my ruler, and I need my black pen, which I already have. Okay. So, O, always in the center. F is still 3. 2F then is 6. 3. Object distance is 2. So it's right here. It is like not cooperating today, guys. Sorry. Maybe I need to just be. Object height is 1 centimeter. Okay. Orange ray goes in parallel and refracts through F. My blue ray this time is a little bit trickier. It's gonna have to do one of those numbers where it goes through F prime first, then to the top of my object. Now, if you're noticing, this blue ray and this orange ray are never going to meet. So, just like I did with mirrors, I need to trace my refracted rays back. Remember, we never trace incident rays back. Just our refracted rays. And then my pink ray, or purple, whatever color you want to call it, goes through O and this doesn't change, so it goes like this. So my 3 lines cross back here. So my image is larger. It is upright. It is beyond 2f prime. And this time it is virtual because it is on the same side as my object. So the image formed on the same side of the lens, so the image is virtual. If a person were looking through the lens, the human brain projects the refracted rays backward, which produces a virtual image behind the lens. Okay, we only have 2 examples left, and those are for our diverging lenses. And I can tell you that with diverging lenses, you always have to trace your refracted rays backwards. So I'm going to do the same colors as I did last time. Oops, that's not purple. So I'm going to use purple there. I'm going to use blue here. And I'm going to use orange here. All right, setup time. I am so tired of measuring 3 centimeters. So thankfully on number 5 it's a little bit different. Oops, didn't mean to do that in orange. Wanted it to be black. Here's O. Now, for a diverging lens, F is on the left. So, 1, 2, 3. Here's F. 4, 5, 6. Here's 2F. 1, 2, 3. Here's F prime. 4, 5, 6. 2F prime. My object is located at 7 centimeters. And it is 2 centimeters tall. So just like this. Here we go. Ray 1 goes in parallel and then refracts out as though it comes from F, but it gets extended back. So I need to line up F and where my incident ray meets. So this is my incident ray. But I need to trace it back. Ray 2 goes toward F prime and then when it refracts, it goes out parallel. And again, I need to trace it back. And then finally, through the optical center. Now, that one I don't have to trace back because it's this one, right? It doesn't get bent. So, this is where my image forms. So it is smaller. It is upright. It is inside F. and it is virtual. If you think you've got it, go ahead and try example 5 on your own. Pause the video, but I'm going to go ahead and do that. So if you think that you want to try it on your own, then pause the video and see if you do it correctly. O, always in the center. This time F is only 2 centimeters. 3, 4. That is also where my object is located. You'll notice DO is 4. So that's where 2F is. My image is 1.5 centimeters high. Why can't I just get this to work every time? Ray 1. Into the center of the mirror or lens, refracts from F. Again, gets traced back. Ray 2. Go. Goodness, I'm struggling today, guys. Ray 2. Maybe if I use my mouse. Nope, can't use my mouse on that. Scratch that. Goes toward F prime. And then comes out parallel. And then finally, the last ray through the optical center. Image forms here. Smaller, upright, inside F, and virtual. Now, on the next 1, 2, 3 pages, there are 9 practice problems. That is your second assignment today. When you have finished that, you are done for the day.